Welcome to our 12th in the series of Rare Rev-inars, and thank you for joining us. I'm Nicola Miller, co-founder and creative director at Rare Revolution magazine, and in the background working on the tech today, as always, I'm joined by my colleague Becky Pender. Today's conversation, which is supported by our friends at Inisio Medical, aims to shine a spotlight on neurological features of inherited metabolic disorders. We've got a great panel guiding us through the topic today, and if you do have any questions, please use the Q&A feature, and we'll do our best to get to as many of these as we can at the end. Thank you also to the many who've submitted questions ahead of time, which we'll also hope to endeavour to answer throughout this session. In the meantime, I am very pleased to welcome Rachel Hatfield, Managing Partner at Inisio, Jonathan Gibson, Policy and Public Affairs Officer at Metabolic Support UK, Vidya Srikantam, Consultant in Paediatric Inherited Metabolic Disorders at Birmingham Women and Children's Hospital, and Hannah Young, Midwife and Parent Carer. Thank you all for speaking with us today and for joining me. I'm really pleased to have you all on. Welcome. As always, when I do a session, I like to start at the beginning and really set the scene. So Vidya, if I'm going to come to you first, just to get some real background here, what are inherited metabolic disorders, IMDs?
Thank you, Nicola. Before I answer the inherited metabolic disorders question, I just want to briefly mention about metabolic reactions. So metabolic reactions are chemical reactions in our body, which are sort of controlled by gene changes. And metabolic disorders happen when, because of the gene changes or spelling mistakes in the genes, the chemical processes are not happening properly in the body. I'll give you an example of these chemical reactions. The chemical reactions can be body making energy from the fats, proteins, and carbohydrates, or it can be getting rid of toxins. Body has a natural detox mechanisms happening, like in the liver, getting rid of ammonia, which is a very nasty toxin. So if for any reason the genetic changes are sort of influencing the chemical reactions, these processes do not happen, and we look after children with inherited metabolic disorders due to these gene changes.
Thank you. And more specifically, neurometabolic disorders, what are they and what are the key differences between those and the IMDs?
So there is a significant overlap. Neurometabolic disorders are a part of inherited metabolic disorders, but their main presentation is usually neurological, which means interfering with the child's normal development, causing them to forget what they have learned, called developmental regression, or seizures. So they have mainly neurological manifestations, or it can sometimes manifest just as a behavioral problem. And sadly, there are more of neurometabolic disorders without any treatment. Whereas if you look at the inherited metabolic disorders as a group, as a broad category, there are disorders with treatment. For example, the urea cycle disorders, where the body is not able to detoxify the ammonia properly. There is a specific treatment for it. So the main difference is the presentation of neurometabolic disorders, which involve mainly the neurology manifestation.
Brilliant, thank you. That really helps set the scene. And Rachel, Vidya's kind of touched on this a little bit, but many relevant rare diseases are not recognised as neurometabolic. What impact does that have on research and understanding this group of conditions?
It's a good question. I mean, I think that the challenge with many rare diseases, including the neurometabolics, is the fact that not just they're uncommon, which is probably fairly obvious, but also they're heterogeneous. So they're highly varied populations. So when you're looking at developing any sort of robust understanding of the disease itself, its natural history, what's driving the disease, the full range of manifestations and presentations, and the likely timing of progression and the nature of that progression across different patient population types, it's problematic. And really, to be of value and provide meaningful information, research has to focus on reducing the number of variables in the mix. So to really unpick what impact individual factors have in terms of the disease itself and how it progresses. So the fact that these conditions are so complex and there's so many things to be looking at can slow the understanding of the interrelationship between factors and then the impact on disease progression and the assessment of the disease as a whole, including the sort of relative importance of neurological effects versus anything else. And without a proper understanding of the sort of totality of that disease, you can't really understand the impact of any new interventions, new treatments, and so on. And a further complication of that is, unless you properly understand the disease, you can't educate on it either. So if you're trying to raise awareness about a condition and what to look for, you're stymied by the lack of appropriate data. So that it really does create a significant barrier to not just disease understanding and treatment, but also just general education and diagnosis of these distressing indications, distressing conditions are there.
Absolutely. And staying on the theme of research, Jonathan, how important are registries and ERNs in research when looking at IMDs?
So in terms of obviously neurological sort of presentations of IMDs, as we touched on already, as Rachel's mentioned, they're very complex, and there's a large sort of wide and varied sort of presentation of how they present. And they are potentially small population numbers. So there is a huge need for collaboration, and ERNs and registries facilitate that. So they are valuable tools to progress research for IMDs, enable for the tracking of people living with IMDs over time, while promoting collaboration with the aim of improving outcomes. So the collaborative approach is key to advancing research for IMDs, because if we take a small population and there might be some research going on in a place and that might be done in a silo, you may have the duplication of research where one group of researchers is working on exactly the same thing, and it's like, okay, how do we work together? Can we take to the next step? Does one group know something that another group doesn't? And they can kind of work together, and then that can obviously drive forward the work in this area. I think as well, like, we need to sort of take into account sort of other sort of disease work that's going on. Where rare disease seems like it's quite on its own. It's a little bit of an island, whereas in a lot of other research and things like that, we've got big pushes for things. So we look to the UN Sustainable Development Goals. So we've got Sustainable Development Goal 3, good health and well-being for all. So how do we achieve that? That's through working together, through pulling that research together, and through driving forward that research. We've actually sort of had some first-hand experience of this recently. So we did our Thoughts into Action research project, and we were thinking after it, what should we do? What should we do with this research? And we thought, maybe we should develop a PROM for IMD. So if anyone doesn't know what that is, that's a patient-reported outcome measure. And we were like, that sounds great. I went onto a call with MetaBRN. So if anyone doesn't know what that is, that's Metabolic European Reference Network. And another group in Germany was working on a PROM for IMDs. So instead of duplicating that work, we reached out and said, how can we work together? There's also other areas in which we can collaborate on. So for example, I've had people reach out to me from the Metabolic ERN and say to us, we've seen the work that you're doing, would we be able to collaborate on that? And then amplifies that message and creates a bit of a sort of drive around it to improve that research, basically.
Oh, it's so important, because we know that there's so much of that, like you say, that siloed working that happens. So it's really refreshing to hear that that's the approach. And in terms of a registry, do you have, is there a centralized IMD register, or how is that working at the moment, or is it split into different conditions?
It seems as though it's split into different sort of areas. So for example, one of my colleagues, I've not had specific experience of setting up a registry myself, but one of my colleagues is working on one now called the Inherited White Matter Disorder Registry. And they've said it's taken a lot of work to get ready, and it's getting set up, and you think it's going to be really beneficial. What they've said is that it can be taking a vast amount of time to set up, to launch, and then that's taken a lot of time out of the patient's organisation, and that may create a bit of an exclusive environment as well. So for example, if you have a patient organisation that maybe represents a small number of IMDs, because whilst Metabolic Support UK is encompassing all IMDs, we do have smaller patients' organisations that we support that are potentially condition specific, maybe run by volunteers and stuff like that. So there needs to be a way for the development of new registries that we could sort of maybe take some of the pressure off the smaller patients' organisations, see how we can sort of develop them with like putting less sort of pressure on people and stuff like that, so we can get those sort of benefits of the registries.
Yeah. I mean, it's a topic on its own, isn't it? You know, the burden of registries and how to sort of synchronise those. So thank you for that, Jonathan.